Hey everyone, welcome back to The Explainer. Today we're uncovering the hidden chemistry of the materials that literally make up our modern world. Most of us go through our day surrounded by metals, from the phones in our hands to the cars we drive, without ever realizing that almost none of them are actually pure. Today we're wrapping up Lesson 5.3 completely, taking a deep dive into the truly fascinating science behind metal mixtures.
All right, let's just jump right in with a kind of surprising question. Why would a 100% pure gold ring actually be a terrible purchase? I mean, it sounds completely backwards, right? We're constantly sold on the idea of purity. You want 100% pure juice. You want 100% pure cotton. So naturally, you'd think 100% pure 24-karat gold would be the absolute ultimate standard for a wedding band.
Well, the simple answer here is that pure metals are actually just really soft. If you were wearing a ring made of pure 24-karat gold, it would scratch, it would bend out of shape, and it would literally wear away super quickly with just normal daily use. It just can't handle the everyday wear and tear of, opening doors, gripping heavy things, or even just typing on a keyboard. That's exactly why 18-karat gold, which actually has other metals mixed into it, is way more common. So that begs the question, if pure metals are fundamentally flawed for heavy-duty human use, how on earth did we build skyscrapers, airplanes, and indestructible tools?
That brings us to Section 1. What exactly is an alloy? To get around these engineering flaws, humanity came up with this brilliant chemical life hack thousands of years ago. By definition, an alloy is really just a mixture of different metals that are melted together. Crucially, they aren't chemically bonded. And actually, you can even mix a metal with a non-metal to create an alloy. Think of it kind of like baking a cake. You're melting and blending raw ingredients together into a single, unified mixture, rather than forcing them to undergo a reaction to create a totally new chemical compound.
And you know what's really wild about this? The final properties of these newly melted alloys are entirely different from their original ingredients. When you watch that glowing, molten metal being poured at those crazy high temperatures, you aren't just seeing a pretty blend of colors. You are literally witnessing the creation of a material with completely upgraded physical superpowers.
Let's move on to Section 2, zooming in, the particle theory.
So why does this actually happen? To really wrap our heads around why mixing metals miraculously upgrades their strength, we need to zoom all the way down to the microscopic level. This perfectly illustrates the core concept. On the left side, you've got pure metal atoms. Notice how they're all identical in size and perfectly arranged in neat, regular rows? But then, on the right, look at what happens when we make an alloy. When you drop a different-sized atom into the mix, it creates this severely disrupted pattern. Those perfectly neat little rows, completely gone.
Here is the crucial takeaway. When you hit a pure metal with a hammer, its perfectly uniform layers just easily slide past one another. That sliding is what makes the metal bend, stretch, and dent. But in an alloy, those mismatched, differently sized atoms act like microscopic roadblocks. They disrupt that regular pattern, causing the layers of atoms to basically get jammed or stuck in place. They completely prevent that sliding motion entirely, which in turn massively increases the hardness and strength of the whole material.
If you want a really solid real-world way to visualize this, imagine a pure metal as a perfectly neat, easily shifted stack of oranges at the grocery store. If you push them even a little bit, the entire pile just rolls and slides right out of place. An alloy, on the other hand, is basically what happens when you take a few massive grapefruits and just jam them into that stack. Suddenly, nothing slides easily anymore. Everything is locked down, mismatched, and totally rigid.
All right, Section 3. Everyday alloys around us.
So, how does this microscopic disruption actually build the macro objects we use every single day? Well, the world around you is completely dependent on this grapefruits in the orange stack principle. Just take a look at this data comparing pure copper and pure zinc to their alloy offspring, brass. The difference is night and day. Pure copper is a soft, reddish metal. Zinc is a silvery, less ductile metal. But mix them together into brass, you get this beautiful golden yellow mixture that isn't just way harder, it is vastly more resistant to corrosion. That is exactly why brass is the go-to for plumbing and musical instruments. It can survive moisture and constant handling in a way the pure elements just never could. We can see an even more famous example of this with iron. On its own, pure iron actually isn't hard enough for heavy structural use. And, as we all know, it famously rusts. But it becomes the incredibly tough, literally world-changing material known as steel when we mix it with a non-metal, carbon. Just by adding carbon atoms into that iron matrix, we get a material that's hard enough to build massive suspension bridges. And if you tweak the recipe with some chromium and nickel, it becomes rust-resistant enough for the stainless steel cutlery sitting in your kitchen drawer right now.
This concept is exactly why the silver coins jingling in your pocket aren't actually silver at all. Pure silver is just way too soft and honestly way too expensive to be practical for everyday currency. Modern coins are actually these incredibly hard-wearing mixtures, usually containing copper, zinc, and nickel. They're specifically engineered to survive being stamped with super complex patterns at the mint and then being dropped, scraped, and traded every single day without wearing smooth.
This exact same chemical principle literally keeps us safe in the sky, too. Commercial airplanes are built using an alloy called duralumin. Think about it. If a plane were made out of pure aluminum, sure, it would be beautifully lightweight, but the wings would literally snap off because of the immense stress they take during flight. No way we'd fly in that. But by adding just a little bit of magnesium and copper, duralumin is born. This specific alloy is about 5 times stronger than pure aluminum, giving the plane incredible structural integrity while still keeping it light enough to fly.
And you know, alloys go even deeper than our vehicles. They literally go right inside our bodies. Doctors rely heavily on incredibly durable titanium alloys for things like artificial hip replacement joints. These metallic mixtures have to survive the highly demanding, corrosive environment of the human body, not to mention withstanding the literal, physical grinding of walking every single day for decades. A pure metal simply wouldn't survive the job. It would fail.
Moving on to Section 4, Modern and Super Alloys.
Today, we aren't just making materials that are harder or rust-proof. We're continuously pushing the absolute boundaries of material science with advanced superalloys, stuff that has almost magical properties. Take these eyeglasses, for instance. The frames are made out of nitinol. It's this absolutely fascinating shape memory alloy made of nickel and titanium. What's so mind-blowing about nitinol is that you can literally crush these glasses, bend them completely out of shape, and they won't permanently break. If you just heat them up, they will magically remember their original molecular structure and snap back exactly to their perfect original form. It's like science fiction, but it's real.
As we wrap up this explainer, I want you to try something. Take a second and just look around the room you're sitting in right now. Think about the door hinges, the chassis of your laptop, the structural beams hidden inside your walls, or even the jewelry you might be wearing. We all like to think we live in a world of pure, elemental strength. But ask yourself, how much of your daily life is actually an illusion of purity, secretly held together by the hidden, chaotic brilliance of engineered mixtures? Thanks so much for learning with us today. And remember to keep questioning the science behind the everyday objects around you.